Welcome to Chemistry with Caroline. In this video, we're going to look at how to identify aromatic compounds. So there's three things that have to be true before we can even consider if a compound is aromatic or not. First, it has to be cyclic, so no linear systems would be categorized as an aromatic compound. Second, it has to be conjugated throughout, meaning it has to have continuous p orbitals. The easiest way to think about this is if you could draw resonance structures all the way around the ring and there was nothing interrupting those, that would be conjugated throughout. So pi bonds, lone pairs of electrons, and charges can all contribute to conjugation throughout a cyclic system. And lastly, it has to be planar or very nearly planar. So if all of these requirements are met, the thing that will distinguish if something is aromatic or not is the number of electrons in the pi system. So there's a simple mathematical formula that we can use to predict aromaticity by observing the number of electrons in the pi system and seeing if it fits that formula. So we'll go to the next page and take a look at that. So we can quickly determine aromaticity for any system that is cyclic, conjugated, and planar by using Huckles Rule. So Huckle proposed that you could predict aromaticity in a system by using the formula 4n plus 2. And in this case, n is equal to any whole number. So it doesn't really have to do with your number of electrons, but when you plug a whole number into 4n plus 2, the value you get is equal to the number of electrons in any aromatic system. So if we look at this here, we'll just see a trend forming. So n could equal 0, 1, 2, 3. And if I plugged it into my formula, 4 times 0 plus 2 equals 2 electrons in a system that is aromatic. 4 times 1 plus 2 equals 6. So a system with 6 electrons would be aromatic. 4 times 2 plus 2 is equal to 10 electrons. 4 times 3 plus 2 is equal to 14 electrons. So any cyclic, conjugated, planar system with any of these number of electrons is going to be an aromatic system. So now we can put this to practice by looking at an actual molecule. Here's benzene. It's a 6-membered ring. It's cyclic. It's conjugated throughout. So every carbon is part of a pi bond. It has an unhybridized p orbital on it. And it's planar. And so then what we want to do is count the number of electrons in the pi system there. So I have 1, 2, 3 pi bonds. So there's 3 double bonds in the molecule. Each double bond consists of a sigma bond localized between the nuclei and then a pi bond above and below the plane of the nuclei. And so the pi bonds are going to be what contributes to whether a molecule is aromatic or not, or the electrons in the pi system. And so if I have 3 pi bonds, each of those has 2 electrons in it. So I have a total of 6 electrons in this system. And so now I would say, okay, well, can I make 4n plus 2 equal to 6, right? And the answer is yes, you can. If n is equal to 1, then you get a value of 6. So because the number of electrons in my pi system fits the 4n plus 2 formula, I can say that this molecule is an aromatic molecule. So what happened with this particular theory, like many theories in chemistry and science in general, is they just noticed that there was a particular group of molecules that exhibited a really high stability and a low reactivity, and they realized that the number of electrons in those systems followed a pattern, and that pattern was 4n plus 2. So we'll look at one more example to wrap this video up. So in this example, I have 2 rings that are stuck together. It's a bicyclic compound, but every atom within this cyclic compound is conjugated. So every carbon atom is part of a pi bond. And so we'd count our pi bonds, 1, 2, 3, 4, and 5. So I have 5 total pi bonds. Each pi bond has in it 2 electrons, right, per pi bond. So I have a total of 10 electrons. And if I have 4 times 2 plus 2, that equals 10 electrons. So this is another example of an aromatic compound. So remember, an aromatic compound needs to be cyclic, it needs to be conjugated throughout, and it needs to be planar, and it also has to have 4n plus 2 electrons. This has been a look at how to identify aromatic compounds. If you found this video helpful, please like, subscribe, and share with your friends.